Number 3, what are flaps and what is their function? Wing flaps are movable panels on the inboard trailing edges of the wings. They are hinged so that they may be extended downward into the flow of air beneath the wings to increase both lift and drag. The purpose is to permit a slower airspeed and a steeper angle of descent during a landing approach. In some cases, they may also be shortened. They may be used to shorten the takeoff distance. Number 4, describe the landing gear system on this airplane. The landing gear consists of a tricycle-type system utilizing 2 main wheels and a steerable nose wheel. Tubular spring steel main gear struts provide main gear shock absorption, while nose gear shock absorption is provided by a combination air-oil shock strut. Number 5, describe the braking system on this aircraft. Hydraulically actuated disc-type brakes are utilized on each main gear wheel. A hydraulic line connects each brake to a master cylinder located on each pilot's rudder pedals. By applying pressure to the top of either the pilot's or co-pilot's set of rudders, the brakes may be applied. Number 6, what type of hydraulic fluid does your aircraft use and what color is it? Refer to your POH. A mineral-based hydraulic fluid, MIL H5606, is the most widely used type for small aircraft. It has an odor similar to penetrating oil and is dyed red. A newer fire-resistant fluid, MIL H83282, is also used in small aircraft and is dyed red. Number 7, how is steering accomplished on the ground? Light airplanes are generally provided with nose wheel steering capabilities through a simple system of mechanical linkage connected to the rudder pedals. When a rudder pedal is depressed, a spring-loaded bungee push-pull rod connected to the pivotal portion of a nose wheel strut will turn the nose wheel. Number 8, what type of engine does your aircraft have? A horizontally opposed 4-cylinder, overhead valve, air-cooled, carbureted engine. The engine is manufactured by Lycoming and rated at 110 horsepower. Number 9, what 4 strokes must occur in each cylinder of a typical 4-stroke engine in order for it to produce full power? The 4 strokes are intake. It begins as the piston starts its downward travel, causing the intake valve to open and the fuel-air mixture to be drawn into the cylinder. Compression. Compression begins when the intake valve closes and the piston starts moving back to the top of the cylinder. This phase of the cycle is used to obtain a much greater power output from the fuel-air mixture once it is ignited. Power begins when the fuel-air mixture is ignited, which causes a tremendous pressure increase in the cylinder and forces the piston downward, away from the cylinder head, creating the power that turns the crankshaft. Exhaust is used to purge the cylinder of burned gases and begins when the exhaust valve opens and the piston starts to move toward the cylinder head once again. Remember, suck, squeeze, bang, and blow. Number 10, what does the carburetor do? Carburation may be defined as the process of mixing fuel and air in the correct proportions so as to form a combustible mixture. The carburetor vaporizes liquid fuel into small particles and then mixes it with air. It measures the air flow and meters fuel accordingly. Number 11, how does the carburetor heat system work? A carburetor heat valve controlled by the pilot allows unfiltered heated air from a shroud located around an exhaust riser or muffler to be directed to the induction air manifold prior to the carburetor. Carburetor heat should be used anytime suspected or known carburetor icing conditions exist. Number 12. What change occurs to the fuel-air mixture when applying carburetor heat? Normally, the introduction of heated air into the carburetor will result in a richer mixture. Warm air is less dense, resulting in less air for the same amount of fuel. Use of carburetor heat can cause a decrease in engine power of up to 15%. Number 13. What does the throttle do? The throttle allows the pilot to manually control the amount of fuel-air charge entering the cylinders. This in turn regulates the engine's speed and power. What does the mixture control do? It regulates the fuel-to-air ratio. All airplane engines incorporate a device called a mixture control, by which the fuel-air ratio can be controlled by the pilot during flight. The purpose of a mixture control is to prevent the mixture from becoming too rich at high altitudes due to decreasing air density. It is also used to lean the mixture during cross-country flights to conserve fuel and provide optimum power. 15. Describe a fuel injection system installed in some aircraft. The fuel injection system injects fuel directly into the cylinders or just ahead of the intake valve. It incorporates 6 basic components. Number 1, the engine-driven fuel pump provides fuel under pressure from the fuel tank to the fuel air control unit. Number 2, the fuel air control unit meters fuel based on the mixture control setting and sends it to the fuel manifold valve at a rate controlled by the throttle. Number 3, fuel manifold valve distributes fuel to the individual fuel discharge nozzles. Number 4, the discharge nozzles are located in each cylinder head. These inject the fuel-air mixture at the precise time for each cylinder directly into each cylinder intake port. Number 5, the auxiliary fuel pump provides fuel under pressure to fuel air control unit for the engine starting or the emergency use. Number 6, fuel pressure and flow indicator measures metered fuel pressure flow. Question 16. What type of ignition system does your airplane have? Engine ignition is provided by 2 engine-driven magnetos and 2 spark plugs per cylinder. The ignition system is completely independent of the aircraft electrical system. The magnetos are engine-driven, self-contained units supplying electrical current without using an external source of current. However, before they can produce current, the magnetos must be actuated. As the engine crankshaft is rotating by some other means, to accomplish this, the aircraft battery furnishes electrical power to operate a starter, which, through a series of gears, rotates the engine crankshaft. This, in turn, actuates the armature of the magneto to produce the sparks for ignition of the fuel in each cylinder. After the engine starts, the starter system is disengaged, and the battery no longer contributes to the actual operation of the engine. 17. What are the 2 main advantages of a dual ignition system? A is the increased safety. In case one system fails, the engine may be operated on the other until a landing is safely made. And B, more complete and even combustion of the mixture and consequently improved engine performance. For example, the full fuel-air mixture will be ignited on each side of the combustion chamber and burned toward the center. Question 18. What type of fuel system does your aircraft have? The fuel system is a gravity-fed system. Using gravity, the fuel flows from 2 wing fuel tanks to a fuel shutoff valve, which in the on position allows fuel to flow through a strainer and then to the carburetor. From there, the fuel is mixed with air and then flows into the cylinders through the intake manifold tubes. Number 19. What purpose do fuel tank vents have? As the fuel level in an aircraft fuel tank decreases, a vacuum would be created within the tank, which would eventually result in a decreasing fuel flow and finally engine stoppage. Fuel system venting provides a way of replacing fuel with outside air, preventing formation of a vacuum. Number 20. Does your aircraft use a fuel pump? No, the fuel is transferred from the wing tanks to the carburetor by the gravity-fed system. The gravity system does not require a fuel pump because the fuel is always under positive pressure to the carburetor. For some aircraft, where for some reason it is not possible to place the wings above the carburetor, or for which a greater pressure is required than what gravity-fed can supply, it is necessary to utilize engine-driven fuel pumps and auxiliary fuel pumps as backups. Number 21. What type fuel does your aircraft require? Minimum octane rating and color. The approved fuel grade used is 100 low lead, and the color is blue. 22. Can other types of fuel be used if the specified grade is not available? Airplane engines are designed to operate using a specific grade of fuel as recommended by the manufacturer. If the proper grade of fuel is not available, it is possible but not desirable to use the next higher grade as a substitute. Always reference the aircraft's AFM or POH. Autogas should never be used in aircraft engines unless the aircraft has been modified with an FAA-issued Supplemental Type Certificate, STC. Number 23. What color of dye is added to the following fuel grades? 80, 100, 100 low lead, turbine. 80 is obsolete, it's red. 100 is obsolete, it's green. 100 low lead is blue. Jet A is colorless or straw. 24. If a non-turbine piston engine powered airplane is accidentally fueled with Jet A fuel, will it start? Yes. Reciprocating engines may run briefly on jet fuel, but detonation and overheating will soon cause power failure. When an aircraft that requires avgas is inadvertently fueled with Jet A, there's usually a small amount of avgas remaining in the aircraft's fuel system, tanks, fuel lines, carburetor, etc. This remaining fuel can enable an aircraft to taxi, perform an engine run-up, and possibly even take off before experience a catastrophic engine failure. Note, other than the kerosene smell and the oily feel when rubbed between the fingers, it can be very difficult to visually identify an accidental mixture of 100 low lead avgas, the blue, and the Jet A straw color. Number 25. What is the primary function of the manual primer? And how does it operate? The manual primer's main function is to provide assistance in starting the engine. The primer draws fuel from the fuel strainer and injects it directly into the cylinder intake ports. This usually results in a quicker, more efficient engine start. Number 26. Describe the electrical system on your aircraft. Electrical energy is provided by a 28-volt direct current system powered by an engine-driven 60-amp alternator and a 24-volt battery. Number 27. How are the circuits for the various electrical accessories within the aircraft protected? Most of the electrical circuits in an aircraft are protected from an overload condition by either circuit breakers or fuses or both. Circuit breakers perform the same function as fuses, except that when an overload occurs, a circuit breaker can be reset. 28. The electrical system provides power for what equipment in an airplane? Normally the following: the radio equipment, a turn coordinator, fuel gauges, pitot heat, landing light, taxi light, strobe lights, interior lights, instrument lights, position lights, Flaps, maybe. Stall warning system, maybe. Oil temperature gauge. Electric fuel pump, maybe. Number 29. What does the ammeter indicate? The ammeter indicates the flow of current in amperes from the alternator to the battery or from the battery to the electrical system. With the engine running and master switch on, the ammeter will indicate the charging rate to the battery. If the alternator has gone offline and is no longer functioning, or the electrical load exceeds the output of the alternator, the ammeter indicates the discharge rate of the battery. Number 30. What function does the voltage regulator have? The voltage regulator is a device which monitors system voltage, detects changes, and makes the required adjustments in the output of the alternator to maintain a constant regulated system voltage. It must do this at low RPM, such as during taxi, as well as high RPM in flight. In a 28-volt system, it will maintain 28 volts plus or minus 0.5 volts.